Alright class, inside of your math journal should be your slope spinner. You glued this down in class today and your spinner goes around your brad in the center. I'm holding the video today, so if it's a little shaky, I apologize. Alright, we're going to start with our slope that would be the same slope as our linear parent function. If we start at a point and we go up one space and over one space, we will have the line that would be our linear parent function. Now, a slope is found by getting rise over run. Rise over run. So here we go. When we look at our slope spinner, if I have a point right here, I rise one and I run one, my slope would be 1 over 1. We're going to put a point at the end of our arrow. And our slope was 1 over 1, rise 1, run 1, so the slope is equal to 1. Let's see what happens if we turn our spinner a little bit. Turn your spinner and we're going to make it a little bit more steep. Okay, here's a new point. So now my line is going through the brad at the center, and it's going through a point right here. On this, I would have to rise 1, 2, 3. So my rise at this, for this line, the slope, I rise 3, and then we would have to run 1, 2. So we rise 3 going up, and we run 2 going to the side. If we look at the other side of this, if we look here where it's pointing at the bottom and put a point there, if we go down 3, that's like a negative 3, and we run to the left 2, that's a negative 2, so we go down 3 and to the left 2, our slope would be a negative 3 over 2, and the negatives cancel out, so the slope is 3 over 2. It doesn't matter if we go up from our point and over, or if we go down and over, the slope is going to be the same. If you're going up the mountain, the slope is the same everywhere you're going up. Alright, here, if we go back to our original slope of 1 over 1, I forgot to put the point at the other end, I apologize. If we go down 1 to the left 1, that's negative 1 for going down and negative 1 going to the left. Negative 1 over 1 is the same as 1 whole. So our negatives cancel out and we have 1 whole. Alright, take your spinner now. Let's make this even more steep. Alright, here I have a point at my brad. If we rise 2 and we run 1, so there's where our line is. We rise 2 and we run 1. 2 over 1 reduces to a slope of 2. You can write this as 2 over 1 or as 2. If we rise 2 and run 1 here on the line, the same line would have to go down 2 and to the left 1. So a point at the other side, if we go down 2 and to the left 1, that's negative 2 over 1. The negatives cancel out. Negative 2 over negative 1 would equal a positive 2. And this last one, we had negative 3 over negative 2, and that was equal to a positive 3/2. For slope, you'll want to leave these as fractions or whole numbers. We don't want to use decimals for our slope. That way we know our rise and our run. Alright, taking your slope now, we're going to make it a little bit more steep. If we rise 1, 2, 3 and run 1, we're going to put a point here. We rise 3, we run 1, the slope would be 3. If we have our point at the other end of our line, so we're just making our slopes. If we go down 3 into the left 1, that's negative 3 over negative 1 is equal to negative 3. Now, taking our slope spinner and putting it all the way vertical up and down. Now, for this, if we have a point at our brad and we rise 1, do we run it all? it does not go side to side. So we rise 1, but we run 0. That would look like the fraction 1 divided by 0. Can you have 1 and divide it into 0 parts? No, that is impossible. We call that undefined. If you have a vertical line, it is an undefined line. All right, so far we've used positive slopes only. Notice that the slope for these has been going up. As our slope gets larger, we had 1, then we had 3/2, then we had 2 and 3. As our slope gets larger, the line becomes steeper. And then when we get to our vertical line, it is undefined. So the bigger the slope, the steeper the line is. All right, let's see what happens if our line gets flatter. So we have our line that had a slope of 1. We rise 1 and run 1. If we flatten it out a little bit, okay, here's a new point. We would rise 2 and run 3. We went up 2, so that's a positive 2, and we ran to the right 3. Going to the right is positive. On this side, if we go down 2 and to the left 3, our slope would be -2 over -3. -2 over -3 is the same as a positive 2/3. All right, what if we flatten our slope out a little bit more? Okay, now we have go up 1, rise 1, and we run 2. So our slope for this line would be rise 1, run 2, or 1/2. All right, as we flatten out even more, if we rise 1 and we run 3, our slope would be 1/3. 1 over 3, we rise 1 and run 3. Let's do the opposites of those. If we look at the other side of our line, we went down 1 and to the left 2. That was -1 over -2, which reduces to a positive 1/2. The negatives cancel out. And then when we turned it for the next one, we had -1. We went down 1 and to the left 3, so we have negatives canceling out, and we get -1/3, or excuse me, -1 over -3 would be a positive 1/3. All right, and if we keep going and we get all the way flat, here, if we rise 0, we haven't gone up or down at all, and we run 1, we would have the fraction 0 over 1. 0 divided by anything would give us a slope of 0. If we don't rise at all, the top number is 0. 0 divided by anything is 0. So the slope of a horizontal line going side to side is 0. All right, so looking at those again, if we start with a vertical line, you could not divide by a run of 0. It was undefined. When we had numbers larger than 1, our slope got steeper. Now let's look what happened when we had numbers smaller than 1. We had 2/3, 1/2, 1/3. So as that fraction gets smaller than 1, our line gets less steep until it gets to 0. It gets less steep until it gets to 0. All right, now what happens if we tilt this the other way? What if we have go up 1 and to the left 1? If we go up 1, that's a rise of a positive 1. If we go to the left 1, going to the left is negative. 1 divided by -1 leaves us with a negative answer, so we have a -1. On the other end, if we go down 1, traveling down on your graph is negative, and to the right 1, so we went down 1 to the right 1, negative 1 over 1 would leave us with negative 1. What if we make this line a little bit steeper? Okay, here, if we rise 3 and go to the left 2, rise 3, go to the left 2. If we rise, that's a positive 3. If we're going to the left 2, going to the left on your graph is traveling in the negative direction, we would get negative 3 halves. There's nothing to cancel out that negative. Same thing on the other side. If we go down 3 and to the right 2, it is negative 3 halves for our slope. All right, if we rotate this even more, if we go up 2 and left 1, so we put our point, we rise 2 and go to the left 1, 2 over negative 1 is the same as negative 2. And here, if we go down 2 and to the right 1, going down is negative, going to the right is positive, we would get negative 2 over 1 or negative 2. Making it even steeper, we would have negative 3 over 1. We went down 3 to the right 1, and that's equal to negative 3. Or we could go up 3 and to the left 1, running out of space, up 3 to the left 1, we would get negative 3. So as the absolute value increases, we have negative 1, negative 3 halves, negative 2, negative 3. It gets steeper. And what happened when we changed from a positive slope to a negative slope? Our line started going down from left to right. If we read graphs like we read words, left to right, it starts going down if the slope was negative. Let's flatten this side out a little bit. So here we had our slope of negative 1. If we move it a little bit flatter, we'll put our point. So from our brad in the middle, if we rise 2 and run to the left 3, we rise 2, running to the left 3 is running in the negative direction. So we have negative 2/3. Same thing on the other side. If we go down 2 and to the right 3, it's the same thing as negative 2/3. Flattening this out a little bit. If we go up 1 and to the left 2, that's the same as a positive 1. Moving to the left is in the negative direction, negative 1/2. Or we could say that we went down 1 and to the right 2. And then flattening it out, we have our slope. If we rise 1 and run to the left 3, our rise was positive 1, running was negative 3, so our slope is negative 1/3. Or here we could go down 1, let me move my arrow so you can see, go down 1 and to the right 3. So as the slope got smaller in absolute value, it created a less steep line. All of these cause our graph to have a rotation. If we start with our slope for our parent function of 1, the bigger the number gets, the steeper it is. The smaller the number gets, the flatter it is. On the other side, if we change it to negatives, it makes our line go down or flips it to decrease. There's the bell for the next class. Now, we're going to use this in class tomorrow. If you need to rewind the video, please do that now. Make sure you have all of these points. So a zero slope was flat, a vertical slope was undefined, all of our positives were increasing, and our negatives were a decreasing slope. The bigger the number for the absolute value, the taller or the steeper it is.